Hello and welcome to Mr. Linford's math course. In today's video, we're going to be continuing our discussion about factoring polynomials and the many techniques that we can use to, in fact, go and factor polynomials. This time, we're going to explore the technique of substitution. We're going to talk about what the general problem is when we see the types of polynomials that we would use substitution for. We're going to identify when, in fact, we can tell to use this method, and we're going to go over what the method actually is. So in the first situation, let's take a look at the polynomial 2x minus 7 and all of that quantity squared, and then we're subtracting 3 times the quantity 2x minus 7, and then we subtract 40. That's a very elaborate polynomial. Since this is a large expression, we need to multiply everything out and simplify. We would have to square the 2x minus 7. We'd have to do the box method on that, so we would have to take 2x and a negative 7 and 2x and negative 7. We're going to have to go through and multiply that to get 4x squared, negative 14x, another negative 14x, and a positive 49. So we would end up with a 4x squared, a minus 28x, a plus 49. We'll have to distribute the negative 3 to get negative 6x plus 21 plus 40. We have to combine those like terms together. And we could keep going ahead and doing this. 4x squared, we have a negative 28 and a negative 6, so that should be negative 34x. We have the 49, and the 40 makes 89. 89 plus 1 is 90. 90 and 20 is 110, I believe. So we could go and say, all right, let's factor that down using the AC method. Well, that's a bit elaborate of a problem. Does it look like we could do anything else when attempting to factor this? Because we could go and simplify everything. It's just going to take a bit of work. Rather, do you notice anything about the setup to this? The structure. We're taking a quantity and squaring it. We're multiplying that quantity by another term. And then we're adding or subtracting a constant. Hopefully, you're actually recognizing that this polynomial, this very elaborate 2x minus 7 squared, minus 3 times 2x minus 7, minus 40. Hopefully you're noticing this looks a lot like an x squared, minus 3x, minus 40. Doesn't this look like a quadratic? It sort of behaves that way, doesn't it? We have a quantity we're squaring, and then another quantity times a number, and then just a standard number. This looks a lot like a times bx, a times x squared plus b times x plus c. What we're going to do is we're going to take the fact that this resembles or looks like a quadratic. Rather, it fits the form of a quadratic. We're going to use that idea to factor this down a little more easily than before. Here is the substitution method, the process for it. First, you have to recognize or verify that the polynomial fits the form of a trinomial, and in particular a quadratic trinomial. We have ax squared plus a bx plus a c. This polynomial fits that form where we have a quantity squared, then we have a quantity times a number, and then we have just a number being added on, that constant term. So what we're going to do is we're going to sub in a variable for the binomial. That's the thing that's throwing it off, these binomial terms. So we're going to sub a variable in for that. I'm going to take the variable u. Let u equal 2x minus 7. So we're now going to have u squared minus 3 times u minus 40. These polynomials have the same form. They have the same setup. So my hope is that I can factor this simplified trinomial, this simplified polynomial. Well, let's see. We need to break this down. We could use the box method. we need to get a u squared and a negative 40. So we can have u and u. And what times negative 40 adds to negative 3u? Well, let's see. That should be negative 8 and positive 5. So we factor this down, and we end up with a u minus 8 and a u plus 5. So let me write that down. U minus 8 and a u plus 5. That's what we get when we simplify down, when we factor down this polynomial, okay? Now, how does this help us? Well, we can go and we can substitute the original binomial back in. So instead of having u minus 8, I can have 2x minus 7 minus 8. And then I can sub back in the 2x minus 7 plus 5. This, since I defined what u was, is the same value as before. So let's simplify our answer. We're going to end up with a 2x minus 15 and a 2x minus 2. All we've done here is we said this polynomial looks like a quadratic. It fits the form. So I'm going to factor it as if this binomial was just a single term. I'm treating it as such. So that's why I use what's called a dummy variable. I treat it like it's a variable quantity and factor it down like normal. Once it's factored down, I sub the values back in and simplify to get my final answer. So we might say 2x minus 15 times 2x minus 2 would get me all of this. Now, there's one extra step we need to take. So we've gone through and we simplified the answer, and we've written our answer as a product of factors. Notice, we can keep simplifying. Where in these binomials does it say that we can keep simplifying? Well, hopefully you're noticing that 2x minus 2 has a GCF in it. So I could factor out 2, and we're left with x minus 1, and we still have 2x minus 15. So altogether, this would be our final answer. The idea here is when you have a polynomial that looks like a trinomial, or I should say has the form of a quadratic. So when a polynomial has the form of a quadratic polynomial, then you can use this method of substitution. You would say, well, it's a quantity that's behaving like a quadratic, so let me simplify it as if it was a quadratic, and then just substitute the values back in. Similarly, we're going to use the same idea when we have polynomials of higher order, meaning larger exponents. The idea here is when we have 6x to the 6th minus 5x cubed minus 4, we would say to ourselves, well, this is a 6-degree polynomial. We haven't learned techniques for that. Rather, could I write it as a quadratic? Could I represent 6x to the 6th as a value squared? And could I then represent 5x cubed as a value by itself and then subtract the number 4? The idea here is, can I make this fit the form ax squared plus bx plus c? What squared gets me 6x cubed? Well, 6 is going to have to be on the outside. But what squared gets me x to the 6th? That's the problem. So let's take x cubed. X cubed squared is x to the 6th. And then I can have that quantity by itself right here, and then the number. So this situation fits the form of a quadratic. Let me use a dummy variable. I'm going to use u again. For me, I just always use u. So let u equal x cubed. We are going to see that when we sub this in, it's the same form as a quadratic, where we have a quantity squared, we have a number times a quantity, and then just a number or a constant by itself. So we can factor this down just like normal. We're going to have to factor this using the AC method because it's a trinomial. The leading term isn't a 1. So let's factor this down by AC method. 6 times negative 4 is negative 24. So the factors of negative 24 are negative 1 and 24. Negative 1 and 24. Negative 2 and 12. Negative 3 and 8. Negative 4 and 6. We also have 1 and negative 24. 2 and negative 12. 3 and negative 8. 4 and negative 6. These quantities are the things that multiply to give us negative 24, and we need to find which of them adds to negative 5. That's going to be the 3 and the negative 8. So we can sub those in. 6u squared plus 3u, and then I'm going to add on a negative 8u minus 4. When we sub those in, we're going to go ahead and factor using the AC method, which means factor by grouping. So let's pull out the GCF here of 3u. We're left with 2u plus 1. And let's factor out the GCF here of negative 4. We're left with a 2u plus 1. We can then factor out the common binomial, 2u plus 1, and we're left with 3u minus 4. So we have factored down the form, okay? We factored down the form of the polynomial. We didn't factor the original polynomial, just its form. Now what we're going to have to do is say, well, we really have 2 times u. Well, u, I defined that as x cubed. What we're going to have to do is substitute back in what u is. So I defined u as x cubed. So let's sub that in. And then we're going to add 1 to it. Times 3 times, well, u again is x cubed. And then we're going to subtract 4. This is going to be our final answer. We have broken down the polynomial. We said, okay, as long as it can be expressed as a quadratic, as long as it can be expressed in that form, and we can rewrite it as a quadratic, we can break down the form and then get our final answer. That's the big thing here. We're breaking down the form and then getting our final answer. Let's try a couple practice problems. What I'd like you to do is pause the video, check to make sure that these can fit the form of a quadratic. ax squared plus bx plus c. And then see for yourself if you can break down their forms and then substitute in to get your final value. Pause the video, take a minute to give it a try. Well, as you go through these problems, hopefully you notice that they all fit the form of a quadratic. And when you sub in a dummy variable, here I used u, you're able to come up with what these quadratics might look like or what their form is. First off, we had the u squared plus 2u minus 15. That factored down using the box method into u plus 5 and u minus 3. However, I needed to not only just factor down the form, but I needed to sub back in what u was. So that's where we sub in the x minus 5 and the x minus 5. So x minus 5 plus 5 canceled, so we just had x for the first one. And then x minus 5 minus 3 just gave us an x minus 8 as our final answer. Similarly, in the next problem, we let u be 2x plus 3. So we had u squared minus 6u minus 16. We then used the box method to factor this into u plus 2, u minus 8. Again, that's just the form. That's how the form factored down. We need to sub in what u is. 2x plus 3 and 2x plus 3. So I added 2 to the one of them to get 2x plus 5, and then I subtracted 8 from the other one to get 2x minus 5. And here is going to be our final answer for problem 2. Hopefully you're seeing that, really, as long as it fits the form, we're able to break it down very simply. If you have any questions about this technique or any other problems in the video, or if you want to go over more content or have a comment, let me know. My email is klinford, that's KLINFORD, @wccnet.edu. And until next time, take care.